Okay, this will be the next to the last lesson, and this is going to be volumes of rotation. And with this, we do have a formula. Volume equals pi times, and we will integrate from some a to b. And the integration will be r squared minus little r squared. And what we have to keep in mind here with this is that we're looking for a big radius and a small radius. We will not always have a small radius, so it's okay for that value to be a 0. And sometimes you will have that 0 and sometimes you won't. So we have to be careful with this. Now our radius, that's going to be the distance between a given function and the axis of rotation. And that's what we're going to look at in these next problems. Okay, for the very first part of this, we will need to sketch all of this that they've given us. So for the first part, let's go ahead and sketch the line y equals 2x, and it doesn't have to be perfect, it's just a good old sketch. And then we also have y equals 0, well that's the x-axis. And then we have the vertical line, x equals 3. So that's going to cut this here at x equals 3. Now it is a good idea to go ahead and find their points of intersection. So we need to figure out, well, if I have y equals 2x and x is equal to 3, where do these intersect? We'll just substitute that x value in, and y equals 6. So right here at the point 3, 6 is where we have a point of intersection. All right, so now we have our sketch. Now we need to keep in mind that for this whole part, this is going to be considered a solid. So we have a triangle. And what we're going to do is take that triangle and we are going to rotate it about the x-axis so that we have a solid formed, and we're going to find the volume of this solid that's formed. So what we need to do here is define our radius. And this is one of those examples where we are not going to have a small radius because we are flush with our axis of rotation. So to define r, the big radius, which you should always have a big radius, is going to be the distance from your top function to the axis of rotation. So here, that is going to be our big radius. So with that, then let's define that distance. So it's the distance from y equals 2x to y equals 0. So that distance there is 2x. And if nothing else, it really is just a matter of subtracting those. All right, so now we're ready for our volume because we will not have a small radius. So that volume is going to be pi times the integral, and we're going to integrate from 0 to 3 of our big radius squared. And so when we work this out, we have pi times the integral from 0 to 3 of 4x squared. And then we need to integrate that. So we're going to have pi times 4/3 x cubed evaluated from 0 to 3. And then once you plug in your 3, then you can stop here. 3 cubed, 27. And that can be enough. Now you do know with multiple choice you would have to finish this. But with free response, as soon as you plug in your 3, and of course you would plug in 0, but it's not going to generate anything for you, you can be finished. Right, now let's look at part B. We're going to take this same exact sketch. So we do need to re-sketch this. But now we're going to go to a rotation about y equals 6. So again, I'm going to draw my y equals 2x. We need to sketch x equals 3. And we saw that our point of intersection here was the point 3, 6. But now I'm going to rotate this solid about the point, or about the line y equals 6, which is just going to be this horizontal line here. So now this is my axis of rotation. So I'm taking this solid, and notice that when we rotate this, that we will get something that will have a hole in it of sorts. So you're going to have, I'm not very good with drawing this, but you're going to have a lot of emptiness on this part. So you have to consider that empty part. And so that's why we need a small r. Okay, so let's erase some of that terrible work there. And let's see what big R and little r would be. So big R would be our longer radius. So that would encompass this entire portion here. So what would be the distance from here to here? Well, this is the line y equals 6. Down here is y equals 0. So big R would be 6 minus 0. Well, what about little r? Well, little r, let's see what that's going to be. That's going to be the distance from here to here. That's going to be that open portion. Well, that distance there is going to be 6 minus this line here, which was 2x. That's going to define that distance. So really, when we start talking about this volume, we're going to be integrating. And again, it's still from 0 to 3. And we have big R squared, so 6 squared or 36 minus little r squared, which is going to be 6 minus 2x all squared dx. And then we do need to FOIL out that second part. So again, integral from 0 to 3. We have 36 minus, and if we square this, we're going to have 36 minus 24x plus 4x squared. And we're going to have a lot of algebra here from 0 to 3. And so we are going to end up 36's will cancel. And then we'll also have a positive 24x minus 4x squared. And now we can go through and integrate from 0 to 3. And let's see. Let's go ahead and integrate it so we don't need that. So we're going to have 24x squared divided by 2 minus 4x cubed divided by 3. And all of that will be evaluated from 0 to 3. And once you substitute in, you're welcome to stop here. All right, now for part C, and we will now rotate about the line y equals 8. So again, we need to go through and make our sketch of our bounded region again. And so let's see. I don't think my drawings get any better no matter how many times I sketch this. And we knew this was at 3, 6. All right, so now we have our bounded region. And now I want the axis of rotation to be about y equals 8. So the line y equals 8, of course, it's going to be up here somewhere. And so notice now we definitely have a larger gap. And so we'll have to have both big R and little r. So let's see. For R, big R, that's going to be the longest distance. So that's going to be from here down to here. So what would be that distance from here to here? Well, that's going to be 8 minus 0, or 8. And then for little r, well, we have to change that. Let's look and see. Little r is going to be from here to here. That's going to be the shorter of the two. And so that distance is going to be defined by 8, that's the function on top, minus the one on bottom, which is 2x. So now I'm ready to fill in our volume formula. So the volume is going to be pi times the integral, and again we're still going from 0 to 3, and we have big R squared minus little r squared, so 8 minus 2x all squared dx. And then we can go ahead and solve some of this. Now I will leave some of it for y'all to do, of course. Let's see, 8 squared, 64 minus and then we're going to have 64 minus, let's see, 16 doubled, so 32x plus 4x squared. All right, and again, go ahead and integrate, collect your like terms, and do your integration, and then you should be good. Okay, now we're still working with the same basic shape, and really we can pretty much, well, to the point we can just draw a triangle here. And we know that we are intersecting here at 3, 6. And this time, we're going to take this solid, and we are going to rotate it about the y-axis. Well, if we're going about the y-axis, or anything parallel to the y-axis, like x equals 3, we have to change our function from being a y equals to being an x equals. So that means that here y equals 2x is really, I'm going to divide both sides by 2, so it's going to be equal to, or x equals y over 2, or 1/2 y. And by the same idea here, this function down here was y equals 0, so really that one's going to become down here to be x equals 0. So it's still the same function, still the same basic shape, but if we're rotating about the y-axis or anything parallel to the y-axis, everything has to be changed over to be an x equals. All right, so again, our axis of rotation is the y-axis, and we still define our area the same way. Now we are not flush with our axis of rotation, so we will take the function that's the farthest away, or that bounding region that's the farthest away from our axis of rotation, and that's going to be r. So how would we define that? So this is going to be x equals 0, and this line here was x equals 3. So the distance between those would be 3 minus 0, or 3. That's going to be big R. Now we have to figure out, well, what is little r? Well, little r is going to be from here to here. That's going to be the shorter distance. Well, that distance, again, we are going to go from this line here, which we now had to write x equals y over 2, all the way over here to x equals 0, or y over 2 minus 0, which is going to be y over 2, or 1/2 y. Now we're ready to write our volume, which is going to be pi. Now our limits of integration have changed because now we're going about the y-axis, so we, instead of going from 0 out to 3, we're actually going to go 0 up to 6. So we're using the y-coordinate now. So from 0 to 6, and big R squared, well, that's going to be 3 squared, minus little r squared, which is going to be 1/2 y all squared dy. And so here we have pi times from 0 to 6. This is going to be 9 minus, that's going to be 1/4 y squared dy, and you can finish the integration portion from there. Okay, so for part E, again, our same basic triangle. So by now I think we're pretty much becoming pros at drawing this. So we have x equals 3. Again, we have our bounded region, and since we are talking about our axis of rotation now, it's going to be something that is not the y-axis, but it is parallel to the y-axis. We're moving our axis of rotation to be here. So then that means that we still have to change our y equals 2x to x equals 1/2 y. And now we're ready to set up big R and little r. Well, big R, notice here, we're going to be from, our longest distance would be from here to here. That's going to be the longest distance. So that has to be big R, which means we're going to have, let's see, we're going to have 3 minus 1/2 y. So and we set that up. And again, the reason why we're starting with 3 is the same reason why we started with the function on top earlier. 3 is farther to the right, and we want to make sure we have a positive value. So we're going to say 3 minus that 1/2 y. Now what about little r? Well, little r, notice we are flush with our axis of rotation. That's really this whole side here. We're not going to have a little r. We're not going to have any empty spaces. So there's no little r. Or you could think of it as x minus 3 is that second function, and our axis of rotation is also x equals 3. So here there's no distance between those two. They're the same thing. So little r would be 0. Now we're ready to set up our volume. So we're going to have pi times from 0 to 6. And we're going to have just big R squared. So 3 minus 1/2 y all squared dy. And again, here we can pull that out. And then we'll collect our like terms and we'll be ready to integrate this. So we're going to have 9 minus, let's see, 3/2 and 3/2. So that's going to be 6 over 2, which is 3, isn't it? So we're going to have 3y, and then plus 1/4 y squared. And now you're ready to do your integration. All right, and then lastly, we're going to take our same basic shape. So again, we need to sketch our triangle. And this time, we are going to rotate this about the line x equals 4. So we will definitely have a gap here. So we have x equals 3 is here. We had x equals 1/2 y. That's what we had to rename this one. And then we have our axis of rotation, which is going to be over here at x equals 4. So that means that we're taking this solid and we're rotating it about that axis. So we're going to have some gaps here. So the first thing we need to define would be our big R, or the longest or longer radius. So that's going to happen from here to here. That's the longest distance here. That's big R. So that's going to be from 4 minus our 1/2 y. And then little r is going to be the distance from here to here. That's going to be little r. So that distance is going to be 4 minus 3, which is 1. So now, again, we've defined our big R, little r. So we're ready for our integration. All right, so we're going to have pi, and we are going to integrate. And again, we're going to use our y endpoint, so from 0 to 6, of big R squared, so 4 minus 1/2 y all squared, minus little r, so minus 1 squared dy. All right, and so here, once you go ahead and full out, you should be ready to integrate and should be able to get the final answer.